So yeah, can you all see my screen? No, not yet, I guess. 'Cause I have not presented. So yeah, can you all see my screen now? Once again, a very good afternoon. As I said, we are doing some problem solving. So we will stick to Google Meet platform, although I am sending it live on the YouTube also so that it stay recorded. But simultaneously, we will stay at this platform where we can talk and discuss anything needed. So you can watch it from either of the platforms. So my first question is, now remember the problems that I'm going to take today, they are based on what we have done in chapter 2. So the first problem that we have here is, if you have a sheet of white paper to shield your eyes when looking at the sun, the side of the sheet facing you appears black. Which of the visual processes is responsible for that? Thank you, Manu, for pointing it out.
Sir,
Yes, I think now I am audible.
yes, sir.
Yeah. So, as I said, I'm leaving lecture on both the platforms. So, if you want to interact with me live, you can interact here. If you just want to watch it, you can watch it on YouTube uh, without yourself being online. So, and of course, you can text on YouTube and participate. So, my first question for the day, if you use a sheet of white paper to shield your eyes when looking directly at sun, the side of the sheet facing you appears black. Which of the visual processes is responsible for that? Chintan, you just close one, na? I can see you either be on the Meet or be on the YouTube. Don't be on both. From my side, there is only one audio. Yes. So, if you want to be in the Meet, be in the Meet, because I don't know. I'm trying this new platform, and let's see how does it work. So if it works fine, then it's fine. Otherwise, we'll see from next time. So, which of the visual processes is responsible for this? So, can anyone tell me? If you have noticed, if you have gone out, uh, suppose if you have a newspaper or a white sheet and it's a very sunny day, you try to use your sheet of paper as a cover on your eyes, as a cap or something, and then you will find that the inner part of that white paper looks very dark. It does not look white. So that is the Which visual process? I think we had discussed it earlier, and it is what we had called is that as brightness adaptation. So if I have to write it here, it's called brightness adaptation. So the concept was that if you plot a graph, let's say if you plot a graph of uh, if you plot a graph of what on this axis, if you plot a graph of brightness adaptation, and on this axis if you plot a graph of absolute brightness, so here I can say how bright it is. If you look at your text, it is given in the form of some formula, but that's not a uh, problem right now. And if I bring keep brightness adaptation here, then what we have discussed is that human eye is basically sensitive to a vast range of brightness. And the scale is logarithmic largely because here a large range is there. However, at any given time, you will find that your our eyes are our eyes can adapt to only a small part of this scale. So if you are say somewhere here, then you can discriminate between these values, but you cannot discriminate between say a value here and a value here. So that is what happens here: brightness adaptation and discrimination. So when you cover your eyes with a white sheet, then outside, since it's a sunny day or looking directly at sun, since it's sun is very bright, you are actually your eyes are trying to get adapt to this kind of brightness, and they would assume that all lower brightness objects are actually dark or black. So that is what we have discussed, and that is the answer. It's a phenomenon similar to uh, if you suddenly from outside, if you go to a very dark region, then you will find that everything looks dark. Say you enter in a theater, but after some time, after some time passes, you find that your light levels comes to the regular. Okay. So my second question for the day is this: you are preparing a report and have to insert it in an image of size 2048 cross 2048 pixels. Assuming no limitations on printer, what would be the resolution in line pairs per millimeter have to be for the image to fit in a space of size 5 cross 5? So if you have a pen and pencil, pen and paper, you can try to solve this. It's a very straightforward question. You have and it's a easy question. You have an image which is 2048 cross 2048 pixels, and you have been asked to fit it in 5 centimeter cross 5 centimeter. And what has been asked is how many, you can forget pairs for the time being. You can, let me simplify it further for you. So what is asked to you is how many pixels are there in per centimeter, or sorry, per millimeter. how many pixels are there in on a per millimeter basis. So instead of line pairs, perhaps we can make it. No, I don't know how to do it in this software, so we'll make changes later. So can anyone give me the answer for this? Either in the Meet or in the live chat or in the YouTube.
Sir, 1700 pixels per millimeter square.
1700 per millimeter square. Um, okay, I will have to just check it. I have not calculated per millimeter square. I have got around 41 per millimeter.
Yes, sir, 41.
Yeah. So you can see that this is a symmetric image, square image, 2048, and this is 5 centimeter. So in order to solve the A part of the problem, all you need to do is you take 2048, because this is my total number of pixels on one side, and the length of the side is 5 centimeter, which is 50 millimeter, because I have been asked in 50 millimeter. So my calculation gives me around 41 pixel. Now this problem I have taken from the book, so you can revisit the problem there as well. So this is how you, so this is one of the solutions. The other solution, second part of the problem, what would be the resolution, have to be in DPI. DPI is dot per inch. So we assume that one dot will represent one pixel. Now we have a 2 by 2 inch we have to fit. So can anyone tell me what would be the DPI image? I mean DPI, how many dots per inch if it has to be fitted in 2 inches? And in the meantime you do it, I will discuss. If you want per square millimeter, then it is 41 into 41, because both the sides have the same dimensions. So 41 into 41 gives me 1681, which is around 1700, as somebody said. So pixel, I will just write px per, so we have pulled off DIP from the exam syllabus. So I'm not going to start anything new. Let me just get deeper into the topics that we have done. Yes, any answer for the B part?
Sir, around a million approximately.
How much? Around a million. See, it's again very straightforward. You have 2048 pixels. As I said, one pixel will be represented by one dot. So that means you have 2048 dots, and you have 2 inches, one edge of the image. So basically it's a similar calculation. 2048 8 divided by 2. This will give you very obvious figure 1, 0, 2, 4, and this is now written in dpi, so dots per inch. Okay, so I hope that solves this problem. Okay, now coming to the paths, consider we have done these adjacent paths and other paths. So consider the two image subsets S1 and S2 in the following figure. Assuming that V is equal to 1, determine whether these two subsets are 4 adjacent, 8 adjacent and M adjacent. So you have been given an image, it's a binary image, so it is either 0 or 1. We have to look at the set of ones. So you have to look only at the 1, 1, 1, 1, 1, wherever 1, 1, 1s are there. Now we have to find out whether they are 4 adjacent. So you have been given two subsets. So this is S1 and this is S2. And it has been asked whether they are 4 adjacent, 8 adjacent or M adjacent, mixed adjacency. So we will use this occasion to revisit these requirements. So 4 adjacent means if you have a pixel P and if the Q pixel is in one of these positions, that is top, bottom, left, right, any of these position is my Q pixel, then we say that it's a 4 adjacency. So this is 4 adjacency, and we have discussed 8 adjacency. This is P. So in 8 adjacency you have top, bottom, left, right, and simultaneously you have diagonals also. So this is called 8 adjacency. Now we will look for the mixed adjacency. So for mixed adjacency, this condition has to be satisfied. That is, the second pixel has to be in one of the 4 adjacent, and the corner pixel does not, I mean, if it is mixed, suppose if I have a P here and so it should be like if Q is here and if this is 0, nothing is there. If this is 0, nothing is there. Then this is a mixed adjacency. While if this was occupied, then it will get into this 8 adjacency. So if you look at this S1 and S2, two subsections, now you can guess what kind of adjacency is there. So if you look at it carefully, you will find that they are not 4 adjacent. Am I right?
Yes, sir.
भाई सब लोग हैं कि नहीं?
Yes, sir.
Yeah, I can see a lot of people today. So you can see that they are not 4 adjacent, but they are Definitely they fall in the category of 8 adjacency, but also they fall in the category of mixed adjacency because this path exists and this is 0. If this is not, had this also been 1 or had this also been 1, then in that case it would not have been a mixed adjacency. But in this case, it is also a mixed adjacency. So wherever the mixed adjacency occurs, you ignore the 8 adjacency. Because in 8 adjacency, there are two paths possible. One is from here to here, and one is from, if this is 1, then it is 8 adjacent, then it is one from here to here and here to here. So there will be two possible paths. So, so I think I can scribble on this. So that is the fun of this medium. That's what I tried, or rather, I will try to draw connected this way. Yeah. So this is my connection in between two regions. It is not a P. P is ruled out. It is not 8 also. Why is that ruled out? Because there is no 1 here. So this is also ruled out. But yes, mixed adjacency is there. So this is my answer for this. Okay, fine. Let's go to the next question. Develop an algorithm for a 1 pixel thick 4 path. So, can anyone tell me what is an algorithm? Have you ever heard of it? Have you ever done it?
Steps which we have to take in order to perform an operation.
Yeah. The algorithm is nothing but the number of series of sequence of steps that you perform in order to carry out one computer programming task. Okay. So we will develop an algorithm for obtaining 1 pixel thick 4 path. We have already seen what is a 4 path. For example, if you look at the previous problem, suppose I take this pixel. Suppose I take this pixel, then you can see that there is a 4 path that exists between these two. Correct? There is a 4
Yes.
path that also exists between these two. And there is a 4 path exist here. There is a 4 path exist here. There is a 4 path exist here. Then there is a 4 path exist here. Then there is a 4 path exist here. There are a lot of 4 paths available. One can always say that this is 4 connect. This one is 4 connected with this one. So this is 4 connection, 4 connection, and 4 connection. So there are a lot of challenges and complications involved, but we can start with some basic ideas. So develop an algorithm for 1 pixel thick 4 path. So you can see that. Can anyone suggest the first two steps? How do we develop an algorithm for?
Check one in its surroundings.
That's right, that's right. So you select any one pixel could be the my first point. Remember the algorithms are written, you will be expected to write algorithm for the practicals when you are doing programming. They are written in English and they give as objectively step by step instructions as possible. So let us consider 1 pixel or any 1 pixel rather. And that could be my first point in writing this algorithm. Okay. Now, what could be the next point?
check for the adjacent elements
Check for the
and
adjacent
pixels.
elements. But would you check all the adjacent element?
No, for the pixel which you have considered.
No, no. For that pixel, there will so many adjacent elements, 8 adjacent elements in the diagonals also. So you will not check the diagonals. You will check only top, bottom, left, and right neighbors. Correct?
Yes, sir.
But what will you check?
If the neighbors are 1.
Yeah, if the neighbors are 1 or in now that was in the previous problem. Okay, if this is 1 and this is 1, so because our set was assumed to be 1, so here you have to check if they are in the same set. So you check for being, or rather I would write pixel values being in the same set. Okay, now if they are in the same set, what will you do? Or rather, if they are not in the same set, suppose I checked one element with its neighbor. Suppose I checked this, suppose I checked this one with this neighbor, and I found that their values are not in the same set. So I will ignore that, right? Isn't it?
Yes, sir.
Yes.
So if they are not in the same set, then ignore. Well, what do you need to do if they are in the same set?
Traverse to their location.
Uh, See, if they are in the same set, we have to declare that there is a four connection, correct?
Yes.
Or a four path exist. So maybe you can set a counter here. So you say that one such connection exists. So you just set a counter which can be starting at 0, and then if two adjacent pixels are in the same set, then increment the counter. So this is my basically an algorithm. Now this is the algorithm for one. This is the algorithm for only one pixel, right? Wait. This is the algorithm for one pixel. Now suppose if I want to take it to the next pixel, what shall I do? Which pixel we should go after this? Can you anyone tell me?
We can repeat the entire algorithm for the next pixel.
Yeah.
So the next pixel would be the pixel which was in the same group.
Yes. So both the things are correct. We have to repeat this algorithm, but we have to repeat the algorithm by the pixel with whom we have got a path, correct? So suppose if I'll go back to my previous question drawing. So suppose if I'm here and suppose I take this one. Now for this one, I will find a four path with this. I will not find a four path with this. I will not find a four path with this. I will not find a four path with this. I can find a four path with this. So with whichever pixel I have found a four path, I will repeat the algorithm. So I can check again its neighbors. Of course, I can put a rider that if I've already checked with some neighbor, then I should not check back with it. That will increase the efficiency. Otherwise, you'll have to recheck. But you have to check with this one. So, so if the two adjacent, this is, so I will leave it right now here. This, when you are implementing, this can be implemented as a function and then it can be repeated as many times as you want. So do remember that is how you write your algorithm. It is written in English. It is written as objectively as possible, and it is the step-by-step steps of your uh, entire program. So please, when you are doing your writing your journal entries, see to it that you write an algorithm and flowchart to all the programs. So maybe in some lecture I will take up writing the flowchart process also. Okay. Now here again something which is based on the set theory. We have to name the sets basically. A is a circle, B is triangle, C is rectangle. So shaded area you have to name. So let me begin with let's say that um, I have a highlighter brush. Let me see what these people do. So it does some shading. But anyway, let's start with this this area first. What is this? The brush only. I need a pen. White. So let us start with this area first. So how do we call it? So let me solve one for you and then remaining three you people can solve. So you can see that this is a part of A and then from this if I take an intersection with B, then I will get this I'll get this entire semicircle. But then from that semicircle if I subtract C, then what is remaining is this one. So this can be written as A and it is intersected or intersection is written this way. A intersection B and from that if I remove C, that means all these parts. So, I mean the upper part is anyway not there in A intersection B, but this corner is there which can be removed by subtracting C. Correct?
Yes, sir.
Yes. So can anyone answer me? I would like somebody else also to answer. What are girls doing for this? There are so many girls in this course. but nobody.
Sir, A intersection C minus B.
Yeah, yeah. Now somebody is talking. So let us write it down. Let's see. This is A. What did you say? Can you repeat?
A intersection C.
A intersection C. So A is, you can see it is intersected with C. So intersection is this way. So now A intersection C will generally give you this vertical semicircle. Now what
Yeah,
after
and
that?
minus B. Minus B.
Minus B. You remove this part here. So you just say minus B. Okay, that's great. So somebody took my challenge, which is nice. Now somebody else should also take it for this shape. Yes, anybody? Can anyone tell me what is this shaded area?
Sir, A minus B union C.
A minus A is definitely there, and you can see that this whole part has been removed. So this whole part belongs to B. Then what did you say?
B union C. No, wait, that doesn't make sense.
Union C.
Yeah.
Union C. कैसे है? Union means addition. So that means that all C will come. But here all C is not there.
Right, okay.
A minus A intersection with B plus C.
A A minus what did you say?
A intersection with B plus C.
Okay, yes, that could be one of the answer, but can you make it even simpler? No, I think what you said last intersection was not correct. It will not be the correct answer. You said A minus B intersection C. Is that you said?
No, sir.
Hmm.
A minus A intersection B plus C.
A intersection B plus C. No, that will not be correct because in that this area will also come. See, the point is I'm asking only for this one.
A minus B minus C.
Yeah, that is the more easier and most elegant solution to this. A minus B minus C. Can you all see this? This is A. Now you remove B, so you remove this half part. And you remove C, so you remove this half part. Correct?
Yes.
Yeah. Now last option, so जो अभी तक नहीं बोला है वो बोलेगा.
B intersection C minus A.
B intersection C. So B is this and C is this. If you take an intersection, this whole thing will come and then you remove A. That's right. That's right. So you say call it B. Then you say intersection. Then you say C and minus A. So that's right. Okay. Great. So there are more practice problems in the book. Please go through them as well. Oh, I have one more problem. So this is the last one. थोड़ा लंबा है पढ़ने में, but I think it's an interesting problem. So can you all read it, or shall I make it bigger?
We can read it, sir.
Fair enough. So, as I said, you must have your pen and paper. So, you can write down the things as you read it. A high definition TV, HD TV. रिमेंबर ये थोड़ा पुराना प्रॉब्लम है. आजकल एच डी टी वी का मतलब होता है यू आर इन 4K अल्ट्रा 6K एंड 8K टी वी. दिस इज नन ऑफ दोज. सो एच डी टी वी generates images with 1125 horizontal TV lines interlaced where every other line is painted on the screen in each of two fields, each field being 1/60th of a second in a duration. So remember, this is talking about old day television set. How many of you have seen old day television set? वो box TV जो होता था. I mean, ऐसा कोई है जिसने नहीं देखा है? LCD TVs are like, for this generation, LCD TVs are there, but earlier LCDs were not there. It was all those box TVs. So box TVs were working by throwing an electron beam on the screen. An electron beam used to scan lines, horizontal lines on the screen. So, and its resolution was defined by number of horizontal lines that the electron beam used to scan on the screen. So right now it says 1125. It is high definition because I remember when I was kid at my home, the small TV. Later on I realized that it has around 480 lines horizontally, which is now typically these days called as 480p resolution. In fact, if you look at those terminologies and those numbers are still prevalent. So if you look at your YouTube video, on the top there will be 3 dots given, and if you open the 3 dots, then the first option that comes is the quality, and that's where you get 480p, 360p, 240p or 144p. These were, now you will ask, from where are these numbers coming? Why 144 or why 240 or why 360? Because all these were the earlier standards of TV. The number of lines the electron beam used to scan horizontally. This problem tells us that it scans 1125 horizontal TV line. You can see it was fairly high number. So it is called high definition. Now it refreshes 1/60th of a second. That means in 1 second, it refreshes the screen 60 times. The width to height aspect ratio is 16:9. So majority of your laptops will have same aspect ratio. So suppose if I have to draw this, then no, let this be my drawing. So ratio of, it is an aspect ratio. So width to height. So if this is the width is this side and height is this side. So whatever is the size of your screen, but if you take, it says that if you take a ratio, then the ratio is 16:9. So this is my ratio of the two. The fact that the number of horizontal lines is fixed determines the vertical resolution of the image. Since I know how many lines are there, this can be calculated. A company has designed a system that extracts digital images from HDTV video. So the company takes the video and extracts images. The resolution of each horizontal line in their system is proportional to vertical resolution of HDTV, with proportion being the width to height ratio of the images. What it means is, it takes the images in the same ratio or same proportion. So if one frame is there, it will create one frame of image. Each pixel on the color has 24 bits of intensity, 8 for red color, 8 for green and blue respectively. These three primary images form the color image. How many bits would it take to store the image extracted by 2 hour HD TV movie? तो 2 घंटे की मूवी है तो उसमें कितने फ्रेम्स होंगे? हाउ मेनी फ्रेम्स आर देयर इन 2 hours HD TV movie? Yeah, so can anyone take some attempt to solve it? Some thought thinking. What should be the first step? So what could be the first step towards solving this? Basically, what you are doing is you have a 2 hours HD TV movie. You are converting it into a frame by frame image and storing them and asking how much memory it will occupy. So the thinking is that you first find out how much memory will be occupied by one frame. What do you need to know to how many, how much would be the memory requirement of one frame? उसको जानने के लिए हमें क्या पता करना जरूरी है?
Sir, I got 2.3 gigapixels.
Very good. Tell me, what did you do? You guide me through the steps.
Okay. So there are 1125 horizontal lines. So the vertical lines would be more because the screen is of the ratio 16 upon 9.
Hmm.
So with that ratio, we can find the number of vertical lines too because they are proportional. So x upon 1125
Okay,
is
let me
equal to
let,
16
let,
upon 9.
hadu, slow. Go slow. So you say that this side is x, don't know how many lines are there, and vertical side you know that there are 1125 lines, correct?
Yes, sir.
So x upon 1125 has to be equal to 16 upon 9. That's what you are saying?
Yes.
Yeah. So that will give you x. How much is x? Can you tell me?
I 16 into I just put the numbers in. I don't have a calculator, so I did all the calculations by the expression in the end, everything in the end.
Okay, you did it. Let me just do it. So 1125 into 16 divided by 9. This gives me 2000. That's right. Correct. So now, so I have got number of vertical lines at 2000 and number of horizontal lines at 1125. What does it indicate?
The number of pixels. If you multiply these two numbers,
Huh.
Then the intersection points would be the number of pixels all over the screen.
That's right. So if I multiply these two, so after multiplication, I will get 2, 2, 5, 0. That's the double of 1125 and 3 more zeros. Correct? So these are my total number of pixels. How many megapixels? Those who understand megapixel language.
2.25, 1, 2, 3, 1, 2, 3. Yeah,
Yeah.
2.25 megapixels.
2.25 megapixels. So each screen has 2.25 megapixels. Now, what will be the next step then?
So we'll have. So first we can write down the factor of 60 into 720. That is 720 is the number of minutes in the movie.
Okay.
Not 120 is the number of minutes. So that I do understand.
Hmm.
And 60 is the number of seconds in 1 minute.
1 minute.
So
You multiply
that
the
would give us the
two.
number.
You multiply the two, right?
Yes.
Yeah. So then,
And then they say that there are 24 bits, 8 into 8 into 8. So that into the number of bits.
yeah. So you have seen that comes first. If you have these many pixels, then each pixel is 24 bits. So you multiply this by 24. Correct? This will give you number of bits in one frame. Now it says 1 by 60th of a second. One frame lasts for 1 by 60th of a second. So total how many frames will be there in 1 second?
60.
60 frames. So
60.
you multiply by 60. This will give you total number of bits required to store 60 frames from 1 minute, sorry, from 1 second of the video. Now you have how many seconds? So as my friend said, you have 2-hour video. 2-hour video is typically 120 minutes video and multiplied by 60 converted into seconds, right? I hope I'm not missing anything else. So yeah, can somebody multiply and tell me how much will this be? 2250000 into 24 into 16 into 120 into 60.
2,
Mine
3, 2,
is
8.
23 gigapixels.
One by one. No, let my friend go tell me all the figure. I'll write. Just promptly tell me. 2, 3. After that,
3, 2, 8.
3, 2, 8.
8, 8, yeah.
Okay.
And then 9 zeros.
9 zeros. Wow. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these many bits, remember this answer has come into form of bits. Normal, now this is what has been asked here. Normal modern day memory is not written in bits, remember it is written in bytes. So 8 bits form 1 byte. So if you divide it by 8, you will get bytes, number of bytes. Those many gigabyte or whatever. So remember this is a 2-hour HD TV movie. And remember this is still far away from 4K. We are still in the domain of 2K. So if you have a 4K movie, it will still be much more heavier to load, download and watch. So I think That was a nice problem solving session. Next lecture also we will take up some more. Yes, Chintan Native Place Box TV. Yes, yes. Native Place even I we replaced it last year only. So in Bombay we replaced it 10 years away or 10, 12 years before. So the world is changing. I saw a demo of a TV which is rollable TV. So you can roll it. I would like you people to check its video. So it's actually kept in a box, and you press a button and it unrolls and stands automatically. Then you can watch whatever you have seen, and then you press the button and it rolls, goes inside the box, and box closes. So it's a lovely concept. That's, I think, will be the next breakthrough in TV technology, when the TV will go folding and rolling. So in your homes, you don't have to keep it on a wall. You don't have to engage a wall with the TV. You just roll it, keep it away, and then whenever you want to watch it, you just go ahead and watch, open it and watch it. Yeah. Any other point you people want me to talk, discuss, or you people want to say? By the way, there was a news that Saturn and Jupiter are very, very close. Somebody had shared an image also that day, which was a nice image. But that is a, I think, a once in a thousand year phenomena or something like that, where the angular separation between Saturn and Jupiter is less than a degree. So it's there in the sky these days. So please don't miss it whenever.
Sir, like I'm going every day at like after 9 to the terrace, but I'm not able to see anything. That photo my friend clicked. I don't remember the place from where he clicked, but I think we'll have to see. Will it be like visible from India or not?
It's visible from
No,
my
it's
place. I think
visible.
I
It's
saw it
visible.
last night.
अगर इस,
I'm not able to see, man. Yeah, like I go every day, and today it's going to be like it's going to be at its peak, and after today it won't be again seen. So I hope like we get to
no,
see
it
it.
will be seen still. It will be still seen closer. But all I'm saying is that I think the sky may not be clear at your place, some cloudy or some situation, because
That is.
Saturn won't be seen if it's cloudy.
And Chintan, don't go so late. You have to go a little early because I guess around 9 they go
Far
below the
west.
horizon.
You
Might
go
be that,
early.
might be
You
the
go
reason.
around 7 o'clock or something.
Actually, like today, I'm planning to sit on the terrace from 6 o'clock to see. Let's see.
Yeah, yeah, yeah. So if you happen to get some photos, please share. I have shared the
Sir,
attendance link. हाँ बोलो.
Yes, sir.
sir, that those things which we do when we apply those dark filters and all to astronomical images,
Hmm.
I'm not sure, like when we do it. So will we learn that in DIP class this year? All those things.
I really exactly don't. We are going to learn lot of filters. So I mean, some of them we have already learned. Like we have learned averaging, we have learned sharpening. In fact, we have learned darkening also, by which like you can apply it, reduce the intensity, increase the intensity by adding. So we have done it. Now I don't know what particularly to which filter you are talking. If you can be specific, maybe I can give the answer more clearly.
So when we take a photo, then with the astronomical photos, night sky photos,
Yeah.
then we have to process it. So my friend and me, when we go on trip, he does this thing where he applies dark filters and a little dark filter and then light filters to the photo. And after a lot of filters, the images come out to be perfect, the star images. I don't exactly know what that is.
No, yeah, I mean, I have not heard about dark and light filters. Filters have some name. So filters fall in the category. There is a one class of category which is called as blurring. So in the blurring filter or averaging, there are categories of blurring. So now today we don't have time. Do we have a lecture tomorrow? Yeah, I think so. Tomorrow is the last lecture date. If I'm not wrong? Since when your lectures are be getting off? 24th onward, correct?
Yes, sir.
Yeah. So tomorrow I think I have a lecture. Tuesday I don't have a lecture. So tomorrow maybe I will discuss what you are talking. Some of the I will keep extract some of my astro images, keep them open, and I will process them uh, by software so that we can see how it works out. Uh,
Okay, sir. I also keep the pictures ready so we can discuss how we can
yeah,
improve them.
but then if you can tell me the name of the filter, then it will be more easier to talk. We are going to learn, I mean, that's how these filters are applied, the way we have discussed. Just that the software like a Photoshop or a Lightroom or Affinity Photo or something like that gives you a much more smoother user interface. Uh, what we will, as I said, we are not learning to make, we are not learning to use those. Purpose of DIP course is not to make you a user. The purpose of the DIP course is to make the designer of that particular software. So I want you to go on the pixel level and write a code so that you can control the brightness. What do you do to control the brightness on your phone? You simply slide a slider, correct? So that anyone can do. That's not DIP. That's a use of DIP. So our purpose is to learn at the pixel level technologies.
Okay, sir.
Okay. So maybe we can stop here today. Tomorrow we can, as I said, I really don't want to start with a new topic before your exam occurs and unnecessarily pile you people up with topics. So once the exam get over, so I think between me and Ajay sir, we have decided he will take the first CIA. The second CIA major part I will take. I think he has given you one assignment. Second and third assignment I will give, and you will have to uh, submit a literature review on DIP and not on electronics. Okay?
Yes, sir.
Yeah. So I think we can stop here. Anyone wants to talk anything, discuss anything, ask anything? So just reminding you at the end, please do watch the Saturn and Jupiter, maybe a little bit in the evening.
Yes, sir.
Yes, sir.
Early.
Yeah. Okay. And if you happen to click photos, then do share.
Yes, sir.
Yeah. So, bye.
Bye,
Thank you.
sir.
Bye, sir.
Thank you, sir. Bye bye.